They say EVs have ignited a revolution in the automotive world, but they forgot to mention they're also igniting actual flames. That's right, EVs are catching fire at charging stations, parking lots, and even on assembly lines, raising serious safety concerns. EV manufacturers are taken aback by the frequency of these incidents, and it seems like there's been little progress in addressing the issue. Let's dive into why these fiery incidents are creating such a stir. While initial data suggests that EV fires might not be as frequent as they seem, a closer look tells a different story. Studies show that EV fires are proportionately less common compared to internal combustion vehicles. For example, an Australian study found that 0.1% of combustion cars caught fire from 2010 to 2020, while just 0.0012% of EVs experienced the same fate. Similarly, the Swedish Contingencies Agency reported 68 fires per 100,000 combustion vehicles versus 3.8 per 100,000 EVs. However, when EV fires do occur, they are notoriously difficult to manage due to thermal runaway, a self-sustaining chemical reaction that makes these fires harder to extinguish. With a 13% chance of reignition, sometimes even months later, and the immense amount of water required to cool them, like the 45,000 gallons used in a Tennessee Nissan incident, the challenges are considerable. In March, a significant incident in Hackensack highlighted the complexities of EV fires. A smoke detector in a Hackensack parking garage triggered an alarm, leading firefighters to find a burning electric Audi Q5. Extinguishing this fire was no easy feat. It took over 7 hours and thousands of gallons of water to cool the battery and prevent reignition. The intense heat from burning EV batteries, which can reach up to 5,000 degrees Fahrenheit, 2,800 degrees Celsius, far exceeds the 1,500 degrees Fahrenheit, 800 degrees Celsius, typical of combustion vehicle fires. This extreme temperature and the battery's location under the cabin make it difficult for firefighters to access and cool the source. Despite their efforts, EVs often burn to the ground, with the best outcome being to protect the surrounding area. China leads the electric revolution with the most EVs on the road and the most developed charging infrastructure, which unfortunately also means it has the highest frequency of EV fire incidents. Fires occur so often that keeping track has become difficult. Official sources reported over 3,000 fire incidents in 2021 alone. Since then, Chinese officials have stopped releasing such data, likely due to the significant increase in EV numbers over the past 3 years. With EVs making up about a third of China's new car market and over 8.4 million electric cars produced annually, it's reasonable to assume that fire incidents have become more frequent, explaining the lack of updated official data. EVs continue to catch fire, unexpectedly damaging reputations and deterring new adopters. These incidents underscore the urgent need for more research and investment to address the fire challenges associated with electric vehicles. Despite advancements, EV makers struggle to manage fire risks. Last December, a battery fire at GM's factory caused $1 million in damages and required nearly 100 firefighters. Fires also occur at charging stations, as seen recently in Oslo, where an electric bus ignited, causing significant damage. Densely populated areas face major challenges, like the March incident in Colorado, where an EV fire escalated into a full-scale garage blaze. Similarly, in Shanghai, multiple EVs caught fire in a residential garage, causing substantial structural damage. The spontaneous ignition of electric vehicles, EVs, remains a significant concern, especially beyond the well-known issue of thermal runaway. Unlike internal combustion engine vehicles, EVs can ignite even when they are parked and unplugged, primarily due to unresolved design flaws in their batteries and electrical systems. A recent tragedy underscored these risks. A fire on a cargo ship near the Dutch coast, which was transporting 3,000 vehicles including 500 EVs, resulted in the death of a crew member and severe environmental damage. This incident led to stricter regulations, such as the banning of EVs on ferries and advisories, for owners to park them outdoors and away from other vehicles. Such measures reflect the persistent problem of spontaneous EV fires and their associated safety hazards. The prevalence of EV fires has substantial implications for insurance costs. Generally, EV insurance premiums are higher than those for internal combustion vehicles, primarily due to the high costs associated with battery replacement and repairs following a fire. The severe damage from these incidents often results in the vehicle being deemed a total loss. For instance, a Nissan Leaf in Tennessee was declared unsalvageable after a fire. Additionally, the environmental cleanup required due to the contamination from burning lithium-ion batteries further inflates costs. The chemicals released can necessitate specialized remediation to address soil and water contamination, adding to the financial burden on insurers and vehicle owners. As the electric vehicle market continues to expand, addressing these insurance challenges becomes increasingly important. Innovations to mitigate EV fire risks are critical for enhancing safety and reducing costs. One promising advancement is the development of solid-state batteries. Unlike traditional lithium-ion batteries that use flammable liquid electrolytes, solid-state batteries use non-flammable solid electrolytes, significantly reducing the risk of thermal runaway. Companies like Toyota and QuantumScape are leading the charge in this area, aiming to make EVs safer through improved battery technology. Another advancement is the integration of advanced fire suppression systems within battery packs. These systems can detect early signs of thermal runaway and deploy fire retardant materials to contain and extinguish fires before they escalate. Research conducted by the U.S. Army into fire-resistant materials for lithium-ion batteries holds promise for civilian applications as well. Enhancements in battery management systems, BMS, are also crucial. Modern BMS technology utilizes sensors and sophisticated algorithms to monitor battery health and performance continuously. By detecting anomalies and implementing preventive measures, these systems can help prevent overheating and reduce the likelihood of fires. Public education and awareness play a vital role in minimizing EV fire risks. Proper handling, charging, and maintenance of electric vehicles are essential for ensuring their safety. Educating EV owners about these best practices will contribute to a safer future for electric transportation. Industry-wide cooperation could also lead to the development of standardized safety practices and shared knowledge on best practices for handling and maintaining EVs. By fostering a collaborative approach, stakeholders can create a more robust framework for mitigating risks and enhancing the overall safety of electric vehicles. This collective effort will be crucial for maintaining consumer confidence and supporting the continued growth of the EV market.